Hello again. This is another video for the Semester 2 review packet. This is for the parabolas section, so I'm looking at my review I have, and it looks like it's for questions 7 through 11. Again, you can watch the entire video, check your work if you need to. Maybe you just need to watch a few questions, so feel free to skip around if that works better for you. So just to review really quickly, there's actually 3 forms. I didn't write the third one. There's 3 forms that we covered when we talked about parabolas. We did standard form, which I'm writing down right now. Y equals ax squared plus bx plus c. We had 2 other forms. We learned about vertex form, which is y is equal to a times x minus h squared plus k. And factored form, which is y is equal to a times x minus r1 and x minus r2. Just a reminder that that a value in each one, so the a value in front for all of those, remember that controls whether your parabola opens up or down, and it controls how wide or narrow your graph will be. And then from there, if we're looking at vertex form, spoiler alert, vertex form is good at giving you the vertex. So if you remember, your vertex will always be at hk. Your h in that parentheses, remember, lies to you. So the h shifts it left or right, but it lies, and then your k shifts it up or down, and it's honest. With factored form is good for showing you the roots, or zeros, we also called it, and it also lies to you, so it's opposite of what you see in your parentheses there. Alright, question 7 says, for each parabola below, state the transformations, state its vertex, and state its line of symmetry. Remember, line of symmetry, just another name for axis of symmetry, and then sketch its graph. So I didn't include a graph here just kind of for sake of time of the video, but if you have a question about graphing, please email me or ask me and I can send you some steps, or we can go through one together. So notice these are all in vertex form. So I'm going to write that up here, vertex form. So I'm going to remind myself that the h is left or right and the k is up or down. A value controls whether it opens up or down as well. So transformations, if I'm looking at A, all I have is something in the parentheses, so that 2 in there is going to lie to me. It shifts it left or right. And in this case, it's going to shift it 2 to the right. Only transformation there. It's vertex. Well, it's in vertex form, so if it's shifted left or right, that's going to be the h value, so it's going to be 2. And then there's nothing added or subtracted out here, which means it was not shifted up or down at all. So the y is still 0, so that's my vertex. And if you remember kind of imagining a parabola, your axis of symmetry goes through your vertex. So my AOS then would just be x is equal to 2. So it's just the x value from your vertex. These two should be the same. Alright, on to B. Y is equal to negative x squared plus 5. I see 2 transformations here. I see a negative out front, that negative right there. That is going to flip my graph or reflect it over the x-axis. It's what makes the parabola open down. And then I also see this plus 5. It's not in parentheses, it's all by itself, so that's my k value. And it's honest, so it's going to be shifted up 5. Or shifted 5 up. Alright, vertex. This guy was not shifted left or right at all, so it's still 0 for x. It was shifted 5 up, so there's my vertex. Axis of symmetry goes through my vertex, so that would be x is equal to 0. Looking at that last one, I can see I have a shift left or right because it's in the parentheses and it lies. So that's going to be shifted 1 left because of the plus 1 and 5 down because of the minus 5. My vertex is then going to be at negative 1. Remember, your h lies. K is honest, negative 5 for the vertex. Axis of symmetry. Remember, it's the same as whatever your x value is for your vertex, so x is negative 1. Alright, number 8 says list the following parabolas in order from narrowest to widest. So remember, when we're thinking about width, we care about the a value out front. An a value that is greater than 1 is going to make it narrower. Sorry for my scribbly writing. And anything kind of between 0 and 1, so greater than 0, less than 1, will make it wider. So they want us to go narrowest to widest. So if I'm going to list the narrowest or the skinniest first, I am simply looking for the biggest a value, positive or negative. So the negative here doesn't matter. Remember, a negative just flips it. So I'm looking for the biggest a value. That would be right here. So my narrowest would be y is equal to 5x squared, or maybe we'll just label that 1, it's the skinniest. Next one would be this 3x squared plus 1. We only care about the a value, which is that 3. So that would come next. Y is equal to 3x squared plus 1. That would be 2. Next I have between a half for this a value, and then this a value I don't see 1, but it's really a 1 that's hiding in front of there. So what some kids get confused here is that this a value is a positive half, and this a value is a negative 1. But remember, the negative doesn't matter when we're talking about the width. The negative just flips it. So really I can just focus on the 1/2 and the 1. A 1 is the standard width. It's going to be wider than that half there. So the y is equal to negative x minus 2 squared would be in third place. And then our last one, which is wider, would be the y is equal to 1/2 x minus 2 squared. So if you want to list that as 4, you could, however you thought of it. Number 9 asked for the coordinate of the vertex for each parabola. Now these are in different forms. A and B are in standard form, and C is in factored form. If you think back to being in standard form, we had a really short formula that we used to help us find the axis of symmetry. Remember, the axis of symmetry is important. It tells us the x value for our vertex. So that is x is equal to negative b, or the opposite of b, over 2a. So for 9a and 9b, I'm going to have to use that formula to help. So let's start with a. Finding my axis of symmetry, x would be opposite of b, so negative 20 over 2 times a, which is 2. So that gives me negative 20 over 4, so x is negative 5. So I have my x value for my vertex. Now I need the y, obviously, because I need the coordinate pair. I'm going to plug that back in. So then I have 2 times negative 5 squared plus 20 times negative 5 minus 5. Follow order of operations. So then I have 2 times 25. 20 times negative 5 is minus 100. And I still have that minus 5 there. Keep my multiplying going. I have 50 minus 100 minus 5. That gives me negative 55. That's my y. So then my ordered pair would be negative 5, negative 55. That is my vertex. For B, same process in standard form, so x is equal to, oh, okay, so here's where you have to be careful. In standard form, remember, we have y is equal to ax squared plus bx plus c. So b is the number attached to x. I don't see anything here. That means b is 0. So I have 0 divided by 2, so x is just 0. Plug that back in to get my y, get 0 squared minus 7, y is negative 7. So my ordered pair is 0, negative 7 for my vertex. C is a little bit different. It wants to be special. This one is in factored form. So if you remember, we know our two zeros are our roots. So here, our zeros or our roots are at 1 and negative 3. That's where our roots are. And I know if I'm kind of trying to visualize this parabola in my head, my axis of symmetry falls halfway between them. So I'm imagining on a graph, I have roots at 1 and negative 3. My axis of symmetry is halfway between that. So I'm going to average those two out. So I do 1 plus negative 3 over 2. That's negative 2 over 2, which is negative 1. That means the x value is negative 1 for my vertex. Then I'm going to plug that back in to get my y. So I have negative 1 minus 1 and negative 1 plus 3. That gives me negative 2 times 2, so y is negative 4. So my vertex is at negative 1, negative 4. Alright, for each parabola shown below, state its domain and range, determine if it has a max or min, and state that value, and write an equation. Important thing here, they say the equation has the same width as y equals x squared. What that means is that a is going to be 1 or a is negative 1. So you just have to know whether it opens up or down, and then you know your a value. So let's start with our domain and range. So for a, and I'm going to have to kind of squeeze this in here. So my domain for A, actually my domain for all parabolas, unless we're in a word problem where we maybe want to limit it, is going to be all real numbers. So I'm just going to state that here all the domains for A, B, and C are all real numbers. The range is where we're going to have some variety. So here the range, if I look at my parabola, I can see that the lowest point it hits right there is negative, oops, I'm a little off, but negative 4. So what that tells me is that all my y values have to be either greater than or equal to that negative 4. I never go any lower than that on my graph. Okay, so A, domain is all real numbers, range is y is greater than or equal to negative 4. I can see that this is a low point of my parabola. It hits a minimum, so I'm going to put min, and that's at y is equal to negative 4. So that's your answer to part 2. It's got a minimum value, and that's at y equals negative 4. So it's just what is the lowest point or what's the highest point. And then writing an equation. So here you have two options. You can write your equation in vertex form. So ax minus h squared plus k, or factored form. Kind of depending what's given to you. For A, I can see my vertex really easily. It's at 0, negative 4, and I can see my roots, so I could do either one. I know in my equation A is going to be 1 because it opens up. So if I write it in vertex form, I'd have y is equal to just x squared is not shifted left or right, and then shifted down 4. If it's in factored form, I'd have x plus 2 and x minus 2, since that's where my roots or zeros are. Alright, let's look at B. So domain, all real numbers still. Let's do range. So here we actually hit a max. Oh, that's way off. But we hit a highest point in our graph right at the top there. So that's at 4, so that means is any other point on the graph has to be less than or equal to 4. Like I just said, that's a max for our graph. That's the highest point it reaches, so it's a max at y equals 4. So that's our answer to part 2. And then equations. Here again you have two options. I can see the vertex really easily. Vertex is at about negative 3, 4. Or I can see the roots easily too. The roots are at negative 5 and negative 1. So I can write my equation in either format. In vertex form, it would look like y is equal to negative 1. A has to be negative, it opens down. H lies, so it's going to be x plus 3 squared, and it shifted 4 up, so plus 4. In factored form, it looked like y is equal to negative 1, x plus 1, and x plus 5. Alright, let's look at our last one. Domain, all real numbers, range here. Looks like I reach a min. That's our lowest point there. Our minimum's at y is equal to 2. So all of our other points on our graph have to be greater than or equal to 2. Here I can actually only write my equation in one format. I can only write it in vertex form. I know my vertex is at 1, 2. I can't write it in factored form because I don't have any zeros or roots. So if I put this in vertex form, it's going to be y is equal to, my a value is 1. I do x minus h, so in this case it'd be x minus 1 squared plus k. My k is 2. Alright, question 11 is our last one for this section. Write an equation for each parabola described below. We'll start with A. When I look at A, it tells me that the x-intercepts are 2, 0, and 6, 0, and the y-intercept is 0, negative 3. If I'm given the x-intercepts are another name for roots or zeros, so I know I want to put it in factored form. So step 1 is decide what form you want your equation in. Next step is to plug in the information that I know. So I know my x-intercepts are at 2 and 6. So when I plug that in, that's going to be my r1 and my r2. So now I have y is equal to a times x minus 2 and x minus 6. Okay, so now the only thing I'm missing is that a value at the beginning. That's where that other point, that 0, -3, comes in handy. I'm going to plug in 0 for x and -3 for y to help me solve for a. So if I do that, I get -3 is equal to a, 0 minus 2 times 0 minus 6. Simplifying my parentheses, I get -3 is equal to a times -2 times -6. I'm going to go over here. I still have a -3 on this side. Keep in mind on the right side, the a, the -2, and the -6 are all multiplying together. So -2 times -6 is a 12, and that's multiplying by a. And then I divide by 12 to get rid of that, and I know a is -3/12, which I simplify to -1/4. So then my final equation would be y is equal to -1/4, that's my a value, x minus 2, and x minus 6, which I had originally put back, or I had originally put in the problem earlier already. Alright, let's look at b. The vertex is 1, -3, and it goes to the point 3, 5. Well, they give us the vertex, so let's use the vertex form for b, which is y is equal to a x minus h squared plus k. Remember, if the vertex is at 1, -3, that is my h and k. So now I know I have y is equal to a x minus 1 squared minus 3, because h lies. And now I just have to solve for a, which is where the other point comes into play. So I get 5 is equal to a 3 minus 1 squared minus 3. Simplify your parentheses. So I get 5 is equal to a times 2 squared minus 3. Next I have to take care of the exponent, so I have 5 is equal to a times 4 minus 3. Remember the 4 and the a are multiplying. So this is where I like to switch that 4 in front of a to remind myself that the 4 and the a are stuck together right now. Now I can add 3. 8 is equal to 4a. I would divide by 4, and I get a is equal to 2. So now I'm going to rewrite my full equation. Y is equal to 2 times x minus 1 squared minus 3. Thanks for watching.